Next is the part of calculation of quartile deviation. Calculation of quartile deviation. How to calculate the quartile deviation? It's very important. So I am giving you one data set where the values are given with respect to the frequencies, and the values are like this. And the frequencies are like this. Frequencies are 361, 132, and then 153, 140, 51, 3. So these are the things given. So in this kind of cases, if they ask you to find quartile deviation, your job is to find the Q1 and Q3. So but the formula I have shown before, that is applicable for bigger cases. But what happens in the smaller cases of quartile deviation? In this kind of cases, Q1 is n plus 1 by 4. Q1 equal to n plus 1 by 4th item, and Q3 equal to 3 into n plus 1 by 4th value. These are the two important things, Q n plus 1 by 4 and 3 into n plus 1 by 4. So how to find it? So first you need to find the cumulative frequencies, which is very easy. 364, 196, 533. No, this should be 540, 543. Okay. So now Q1, if you put the value, so Q1 is 543 plus 1 by 4, so 544 divided by 4, 544 divided by 4, that is 40. So this is very important from this area. So it is a 136th value, 136th value. Now according to this pattern, 136 value is what? 136 value is directly till this, from 64th value to 196 value, every value is 40. So this value is directly 40. Even in this way, 3 into 136, that is 408 value. Where the 408 lie? Within these two. So within these two, this every value is 60. So that value is directly 60. Okay. So this is 60. So what is the value of Q3 minus Q1 by 2? So you can guess it directly, 10. So this is the value of quartile deviation in any kind of sum. Next is mean deviation. The next concept with respect to dispersion is mean deviation. Mean deviation, just by the word deviation or fluctuation from mean, with respect to mean where the fluctuation is actually going, and it has a very basic formula, that is mean deviation is 1 by n summation of xi minus x bar. Summation of xi minus x bar. This is the mean deviation. Okay. So this is the calculated mean. This is actually the MD, the calculated mean. The deviated mean which you need to calculate. One question you can get the idea, and remember that this modulus is very much needed. This modulus is needed. One example. If it is with frequency, then what is the value? 1 by capital N summation of f of xi minus mt. 1 by xi minus mt. So I am showing you one example where the values are little bit different, fluctuating. So here we go. Okay. RDC দেখাচ্ছে তো? So one example.
MD is the calculated mean.
Yeah. So here the values are 15, 20, 17, 19, 21, 13. 15, 20, 17, 19, 21, 30, and then 12, 10, 17, 9, 12. So you have a set of 11 values. Okay. Now here you need to calculate first your calculated mean. Step 1. So what is MD over here? If you just calculate, this will give you 165. The total will come 165 divided by 11. So you can directly write this as 15. So the first step is x, and next line you have to find out x minus 15. X minus 15 with a modulus. X minus 15 with a modulus you need to find out. What is x minus 15 with a modulus? So you will get the possible values, that is 0, 5, 2, 4, 6, 2, 3, 5, 2, 6, 3. As I have taken modulus, so you don't need to consider anything else. So here the value of the mean deviation MD is summation of xi minus 15 by how many values? 11. So 5, 7, 11, 17, 19, 22, 30, 35. So this total gets you to 38. 38 by 11 is 3.45. 38 by 11 is 3.45. Okay. So this is the basic kind of a structure for mean deviation calculation. But if you don't take this modulus, you may end up with a zero answer. So the note is the modulus is needed. Okay. Next part. In the deviational calculation, we have another important thing coming out, that is coefficient of mean deviation. Coefficient of mean deviation. Okay, this is nothing but mean deviation divided by x bar. Coefficient of mean deviation is nothing but is MD divided by x bar. Okay, this is the coefficient. In generally, this will be a positive value. Now coming to the next part, which is the most advanced and important segment for this calculation, that is called standard deviation. This one is called standard deviation. What is standard deviation? So the standard deviation calculation is on the basis of this kind of structure, that is function of x by